Hi students, we're going to work on a piecewise defined function. You can notice that it looks different than most functions you're used to because it has two parts to it. Sometimes these piecewise functions also have three parts to it. Depends on what you're given. So what this means is that we have two pieces of the function and each piece is valid for a certain part of the function's domain. So for example, it's telling us to use f of x equals 10 plus 2x if x is between 0 and 20. 0 is less than or equal to x is less than or equal to 20. So I'm going to write that here so I remember what my domain is, that those are the only values of x I can use this function, this part of the function for. So what I like to do is I like to use the endpoints, 0 and 20, and I'll choose another value of x in between, and why not choose 10 right in between 0 and 20. But you could use anything between 0 and 20. And we're going to calculate f of x. So f of 0 is 10 plus 2 times 0, which is 10. F of 10 is 10 plus 2 times 10, plus 20, which is 30. And then f of 20 is 10 plus 2 times 20, 10 plus 40, which is 50. So let's go ahead and graph our ordered pairs. We have a distinct starting point and a distinct ending point to this part of our function, so it's just going to be a line segment. And at each end I'm going to put a solid dot because it has the less than or equal to here. So at x equals 0, which is the origin right here, f of x, or f of 0, is 10. So 0, 10 is my first ordered pair. And then if x is 10, f of 10 is 30. And if x is 20, f of 20 is 50. So these should be right in a line. How do I know that? Because if I look at the function 10 plus 2x, it's written in the form of y equals mx plus b. If I rewrite it as 2x plus 10, you can see the slope of this line is 2, and the y-intercept right there where the graph crosses the y-axis is at 10, 0, 10. So let me go ahead and draw a straight line through these 3 points, and that's 1/2 of my function. I'm not done yet though, because I have another part of it. F of x is also the rule 40 plus x if x is greater than 20. So any numbers of x bigger than 20. Now one thing I am going to do is put 20 in for x here, but I'm going to put brackets around this. And I'll explain why in a minute. So if we calculate f of 20, I have 40 plus 20, which is equal to 60. This gives us a starting point for this part of the function. But because x is going to be greater than that point, if I go to 20 and then I go up to 60 right here, I'm not going to put a solid dot, I'm going to put an open dot, because that is where this part of the function is starting, and it will continue on from there. But it's not defined for x equals 20. That's the reason why I'm putting it in brackets, just to kind of, it's a mental note to myself to be careful that that is not part of the domain, but it gives us a natural starting point. Let me let x be equal to 30. So f of 30 is equal to 40 plus 30, which is 70. So if x is 30, f of x, or y, is 70. And we'll do one more point. Let's let x be 40. So f of 40, 40 plus 40 is equal to 80. So if x is 40, f of 40, 80. This graph will start at this open circle and continue in a straight line to the right forever, because our domain of this part of the function is that x is greater than 20. There's no ending point. So as you can see here, it's called piecewise defined because we have this break right here. We have half of the function down here and the other half up here, both defined by two different function rules. I'll see you soon. Bye.